Hello everyone. So in the previous lecture, this is lecture number 6, we have discussed the circuit. There is a simple RC circuit with the square signal of 0 to 5 volt. Okay, where we have considered three conditions: T very greater than RC, T less than much less than the RC, and T equal to RC. Where T equal to RC was the homework. Now we will discuss from the lecture 7. The input excitation is changed to the current. Okay, so instead of using means voltage input, I am considering there is a current input. This is changing from 0 to 5 amp. So what I can also draw this diagram like, okay, this is my R, this is a C, and what we are applying, we are applying a current source which I call the IN, and this IN is suddenly changing from 0 to 5 ampere. Okay, so IN 0 means, IN 0 simply means open circuit. Okay, open circuit, no current is there, so I expect that VC 0 negative is 0 volt, because your circuit was open for a long time, and I'm considering that there is a no initial charge. Okay, we will consider all these circuit combinations whatever we have discussed till now with the initial conditions as well, but as of now I'm not considering any initial condition, and we have taken the current as a input here. Okay, so VC 0 negative is 0, and when we applied a current suddenly at t equal to 0, so what is there at t equal to 0 positive, what is the IN? IN is your 5 ampere current. So we have to figure out what is your VC 0 positive. So anyway, we can see VC 0 positive nothing but VC 0 negative, because capacitor will hold its value is 0 volt. And after that, what we are seeing that capacitor is having some constant current source at t equal to 0 positive. Okay, so we can also consider this circuit as RC V out. So a constant current of 5 ampere is applied to my circuit. Okay, so simply what we can say, this is the only current which is flowing through the resistor and capacitor. So IC is very clear from here that IC is nothing but IC is equal to IN. Okay, so IC 0 negative is equal to what? IN 0 negative, which is equal to 0 ampere, and IC 0 positive is nothing but IN 0 positive, which is 5 ampere. So simply, if I talk about this IC, it is nothing but with respect to time, it is the current which is changing from 0 to 5 ampere. Okay, so this is the current value of the IC current. Now what to speak of the voltage? Okay, what to speak of the voltage of the capacitor? So for the constant current, we know that for constant current across the capacitor, for constant current across the cap, what is the slope of the voltage? Slope at any time t is nothing but that constant current, okay, that I times c. So as we know, at t equal to 0 positive, the current is nothing but IN is 5 ampere. So my slope is simply, slope at 0 plus is nothing but 5 by r. And after any means after the 0 instant, so after t equal to 0, IC equal to 5 ampere forever. It simply means the slope at any instant, slope at any time greater than 0 second is equal to 5 by r. This is an analysis, sorry, not 5 by r, what I have written, 5 by c. Okay, so here I will write to 5 by C. So it is 5 by C. C here, C here. Okay, so the slope is constant forever. Here we are seeing the slope is constant at all time instants. At all time instants after t equal to 0. What to speak of t equal to 0 minus? Here what is the current? IC equal to 0 ampere. So what will be the slope? Slope at 0 minus is this current IC by capacitor value is nothing but 0 by C equal to 0. Okay, so it is for all times less than t equal to 0 sec. Okay, so it simply means if we have having some constant slope of the voltage after t equal to 0 and has 0 slope before this t equal to 0, it simply means we can say directly about the capacitor voltage, or we can see the nature. So what is happening at this is my t equal to 0 instant. So before t the slope is 0 simply means this is something like that. So I'm exactly not talking about what is the magnitude of the means capacitor voltage. So anyway, you can see that it is lying on this capacitor means on the means at zero VC axis, and after that there is some slope. The slope is constant forever. The value of this slope is nothing but what you can say 5 by C. So we are seeing some sort of linear relation for this particular. And this is true also because we know that for the constant current across the capacitor, we are having some voltage which is nothing but increasing linearly. This thing we can see from the equation also. But before the equation, we are looking for this characteristic just by from the slope. Okay. So from slope analysis of capacitor voltage, we can estimate the we can predict or we can estimate some sort of nature of the plot. We can predict the nature of the cap voltage. Okay, so it is increasing linearly that because we are seeing that the slope is constant after t equal to 0 for all the instants. But before t equal to 0 slope is 0 does not mean that vc is also 0. Okay, so t equal to 0 negative slope is 0 doesn't mean that VC equal to 0. Okay, so it is not a mandatory thing, but I have drawn it like VC is 0, but it is not the true case. It depends on what is the initial condition you have. Because now I will write an exact equation for the capacitor voltage and current relation, and from there you can find it. Okay, yes. So what is the exact nature? Exact nature is VCT to 1 upon C. If I am integrating from 0 to T, ICT then there is some initial condition also, that is a VC 0 negative. Okay, so for time less than 0, or I would say this integration is having the current term to be 0, so this is coming to 0. But as we are integrating from 0 to t, before that, that no means what I mean to say, no current is there, so only it is the integration is dependent only on the initial value, and which is 0 volt. I consider that capacitor is uncharged. Okay, capacitor is uncharged initially. It simply means when your integration is going to start, before that the value of capacitor voltage depending on its initial charge value. So initial charge is 0, it means your plot is correct. Okay, Now this thing we can see the exactly slope will come like that only. Okay, so what is the capacitor voltage equation? That is nothing but 1 upon C 0 to T. What is the ICT? ICT is nothing but 5 ampere after the T equal to 0. Okay, dt plus initial condition is 0. What it comes to be 5 by C, and there is some variable, and for the variable the integration term when you put it, it comes to be 5 by ct. So it is nothing but a line equation of a line which has a slope of 5 by c. Okay, so from our prediction that the slope was 5 by c and it should be constant throughout for the t greater than 0, so we were also getting the same nature of the plot. Okay, so simply we can predict about the voltage and the current, and current we can see is constants, is constant for all the time at the 5 ampere. Oh, so this is a very fundamental analysis. The only point to take this circuit was to tell you with the intuition what we can see from the discussion of the slope. Okay, so if now I modify the input a little, what we will see here. Okay, so let I modify the input current. Okay, so if same thing is here, now if this is my I in here and I in is some sort of pulse 0 5 ampere, and again after t naught it is 0. Okay, so one thing what we can see, for t greater than 0, t equal to 0 positive, what we are seeing that slope is 5 by c, that we have seen as of now. And after that this current 5 is staying for t, what I mean to say, for till t naught. Okay, as we are seeing a constant current of 5 ampere, a constant current of 5 ampere is applicable till t equal to t naught. So till that point of time the integration will happen. Okay, so integration simply means the integration of constant comes to be a linear value. So this is vc, or I call v out. So from here what we can see, we have a constant slope because we have a constant current flowing across the capacitor. So the same mechanism is happening here. Till this point we will having the charging. Okay, this is the value T naught. So what should be the value of capacitor voltage at this particular point of time? Okay, so what we are seeing that it is increasing with a slope of 5 by C. What should be the equation of capacitor voltage? Capacitor voltage with respect to time should be what? 5 by his slope times this time. So what is the value of capacitor voltage at time instant t naught? Nothing but 5 by c t naught. Okay, the initial value is 0, so I am not worried about that. So it is 5 by c t naught. So this value comes to be 5 by c t naught. Okay, and after that what is happening? Okay, so after that what is happening, we will see that a current is removed or the circuit is kept open. So what I want to say, t greater than t naught, or I will say just at t naught plus, my circuit is again open because my current to be 0 simply means circuit is open. So whatever amount of capacitor has stored, okay, whatever amount of voltage capacitor is stored will stay there forever. Okay, so I need not to say anything about IC because IC is nothing but equal to I in. Here also you see. Okay, so here in this case also I C is equal to I in. So the plot is going to be same for the I in as well. 0, 5 ampere and 0. Okay. So need not to say anything about the IC. But what will happen at t equal to t positive, our circuit is open here because the current 0 means simply circuit is open. So capacitor will hold its value whatever it got. Okay, and it will hold this value forever. So this will capacitor will hold its value. capacitor will hold its voltage value or charge its voltage forever after t equal to t naught. Okay, it will hold its value. It's a simple thing. So if we are having some sort of pulse, then we will see this thing also, what is happening there. Okay, so now the pulse means a repeated signal that I want to place here, the current, but a repeated signal. Okay, so here the current that I am applying here, so this is nothing but T. So here I am not concerned about that what is the relation of T with RC, because we are not seeing that there is any charging or discharging or exponential nature is not applicable here, because we are applying some sort of constant current, so constant charging is happening. Okay, 5 ampere and 0. Okay, so I'll just mark few time instants so that we can have a better discussion. One time instant, this is my 0, this is my T by 2, this is T, and this time instant comes to be 3 by 2, and following this to 2t. So these are the time instants. Okay, so what is happening from 0 to t by 2? From 0 to t by 2, a constant current is applied. Initial condition is 0. So current plot of capacitor is same as the input current. I am speaking of capacitor voltage. Okay, so for the time between 0 to t, a constant current, what is the IC? IC is nothing but I in is nothing but 5 ampere. So slope is very clear in this duration is what? 5 by c. So it means exactly the equation will be what? If no initial condition is there, then 5 by c t. So what is the capacitor value at t by 2 is nothing but 5 by c t by 2. Okay, so it simply means this is my t by 2 t 3 by 3 t by 2 2t. Okay, 0. This is my VC, also called the Vout. That I should change the color of my pen. Okay, so what is happening here? Before it was 0, not a problem. So after that, it will increase and it will reach to some value, and this value is nothing but 5 by C into T by 2. And after that, we are seeing that capacitor, oh sorry, the input excitation or current is removed. It means circuit is open, so capacitor will hold its value. Okay, so what will happen at this point? At t equal to t, or I should say capacitor has some initial value at t equal to t. So actually t, we see t negative is nothing but the value it has stored is. So what is the value of capacitor, or I meant to say what is the value of capacitor voltage exactly after t equal to t. Okay, so we can write the equation as well. We see t, if we are integrating from t to t, what is happening there? What is the current? Current is again constant current of 5 is applied here. I should see the 1 by c also here, time dt plus vc t negative. This is the initial condition here with respect to time equal to t. This is the initial condition that was 0 in case of t equal to 0. Here it was 0. Okay, here it was 0. But here the initial condition is there. So what is this? 5 by C. What will be the value here? T minus T plus 5 by C T by 2. So we can see at t equal to, when we put the values of time instant, let's say we put the t equal to t, or let I should say means 1.1 of t, 1.2 t, whatever value of the time we put here, we will get the value at these different instants. But what is the common we are observing here? The slope is again, slope at t equal to 0, t positive itself 5 by c, because this thing is going to be same, because at any instant whenever the excitation is applied, The current IC is nothing but 5 ampere only. The IC is 5 ampere whenever my excitation is applied. Whenever excitation is applied. Okay. When it is not applied, it is simply zero, means it is open circuit. Okay. So the current is same, means at any instant whenever my excitation is applied, at that time the slope will be what? Slope is simply I by C. It is always like that. Okay. When the excitation is non-zero, then slope is non-zero. If IC is non-zero, slope is non-zero, and which is equal to 5 by C. And if IC is 0, then slope is 0. So these are the time from like this value t by 2 to t, and after that 3t by 2 to 2t. In these between, the current is 0 because no excitation is applied here. This reason no excitation is applied here, current is 0, simply open circuit, so capacitor will hold its value. So generally we can write the equations as well, so be aware of this equation as well. Okay, so after the s slope is same, so it will increase. Okay, it will increase the same slope, whatever slope was there between this t equal to 0 to t by 2, the same slope it will increase till this point, and after that it will hold the value, and the same thing it will do for all the cycles. Okay, it will do like this. So it will reach to infinite value whenever we are applying the continuous current, it will remain charging. Okay, so what is the value at this node, you can see by plotting on it, or by putting the value of t equal to 3t by 2 in this equation. So let I put 3 equal to 3 by 2, 3t by 2, and what it will be. Okay, if I put t equal to 3t by 2, then it will come 5 by c. 3t by 2 means 0.5t, 0.5t plus 5 by c, 0.5t. Okay, 0.5t, here is also 0.5t. What it comes to 5 by c into t. Okay, so this is nothing but 5 by c into t. So what we are seeing that because as the slope is same between these all time intervals, so we are seeing that exact amount of voltage will increase on the y-axis. So from 0 to t by 2, what is the point I will tell you here. Okay, so as we are seeing from t between 0 to t by 2, my change of voltage happening is what, 5c by t by 2. So between this also, because slope is same, so between time t equal to t2 3t by 2, again the same change will happen. So same change means one more 5c t by 2 will add in this, so it means this node will be 5c t by 2 plus 5c t by 2 means 5c t, 5c by 5 by c t. Okay, so what will the value here, again in this duration also, what I mean to say, I am adding 5 by c t by 2 here, again I am adding 5 by c t by 2 here, so it is reaching to 5 by c t, and again here I will also add this value to 5 by c t by 2. So what this node will reach, this node will reach to 3 times 5 by c t by 2, which is nothing but it comes to be what, 15 by c t by 2, or it will come to be 7.5 by c into t. Okay, whatever you can see, it will come. So this is the thing that I want to tell you here. Okay, so in the next video we will see some different circuits, possibly with the current source only, and after it we will go to the tutorial session where I will give some homework problem. So I think I could clear my point. This is nothing but a very simple thing, the capacitor charging equation with initial condition or some condition, means as of now initial condition is not considered here, but you can see here the effect of the initial condition is visible here. Okay, effect of initial condition is visible here. This is the effect of initial condition. Okay, so I think rest all thing I could clear here. So my point there was use of slope for your linear charging also. And the point was use of capacitor voltage, slope in linear charging also. Okay, so capacitor slope is always important, capacitor voltage slope is always important. For that you must have the understanding of capacitor current at any instant of time where you want to see the slope. In the linear charging, slope is going to be constant for all the times after some time instant, which is 0 in this case. Okay, so from that perspective only, with the slope analysis only, we can see what is the exact nature of my voltage, okay, which is nothing but a linear in this case. Also, what we are seeing previously, we are seeing that at every coming instant in the previous case, my slope was changing. So that's why whatever when we are considering the voltage case, this was like some sort of exponential was happening there. Okay, because the slope was changing in every coming instance. That's why for the voltage it was coming as an exponential nature. Rather, it is a linear for any time interval if we are applying continuous or can say a constant current there. Okay, so I think I could clear my point here. So this is enough for this video. In the next video, we will see something interesting. Thank you.